Quick introduction to Lego Mindstorms. The first thing you should learn how to do is turn the sound off. Shabam. Okay. I don't know. Maybe it's cool for the first 30 seconds or something, but that really grates on you when you're getting your stuff done. So, we are going to do a quick program on the Lego Mindstorms. I'm not actually going to be able to show you the physical robot for the moment, but it's the basic one that comes with the 45544 set, and that's the intro education set. The robot designs that you see in front of you are for a slightly different set, so you can't build them. Okay, as with the ones that come with the intro to Lego Robotics on their own website. So you have to go out and download stuff specifically for Lego set 45544. At least I think that's what it's called. Anyhow, you'll see it quickly and you'll get some basic designs out and they work fine. So if you want to get a program started, first thing we do is we go to Add Project, like so. This will load for a couple of moments and then you're left with this. This is a block of code. It's a start point for your program. All right. And you basically want to start your program, click. That's about it. All right. And basically what you do is you take a series of blocks. I'm just gonna create like a silly program here for a second. Like this, and you drag them. All right. I don't think it's really essential as far as I can tell, because I'm still learning some of this stuff myself. But I like to put this stop block at the very end, because if from my programming days you have a start of a program, should be an idea that you define conditions for stopping. Okay, I like that better than to just have these blocks go on forever. Okay, it doesn't really do too much other than it allows you to stop the program if you press it. All right, so program flow starts like this. You start your program, execution goes to this block, and then it goes to this block, and then it goes to stop. All right, it's a pretty linear flow here. We have other more complicated blocks we'll get into later, like this loop, all right, here, and like this switch over here, all right, which is like an if-else statement, again, if you do any programming. But we're not going to worry about those for the moment, all right? But needless to say that with a couple of simple blocks like the ones we have, you can have branching and looping and stuff. So, you know, you can actually get some relatively complicated programming dynamics going on here. But essentially, this linear flow thing is what we're going to be doing for today. All right. So if you want to get rid of a block, you'll notice that you just pull it out and you just drag it. And this is basically like where blocks come from, but it's also where like the trash bin at the end. You can, if you want, take a block and move it like that. You can click on a block and then pull it out. Okay. I'm not sure I like this too much. Okay. And I'm still trying to figure out whether or not you can actually take multiple blocks and connect them up. I'm not sure that you can. All right. So I think you can connect blocks, but I don't think you can connect this block to, oh, actually, yeah, there you go. Yes, you can. All right. Not entirely sure how well this bit works. All right. Haven't tested this out. We'll do that in a later video. All right. But notice that you can actually, you know, separate the blocks out. So even though I had it in a linear fashion like this, you don't have to keep it like that. You can actually have more complicated programming dynamics and stuff. Anyways, first thing I'm going to do here is hopefully turn this off. Let's see, there we go, and turn this off and trash this. And we're going to write a simple program quickly, and then I'm going to plug it into my Lego robot. So basically what I want is the robot to move forwards, all right? And for that, I select this block called Move Tank. And you'll notice as I move it close to my start block here, you get that little shadow outline, and that means it's going to snap. So if I let go of the block right here, you'll notice that it snaps. And then I'm going to connect this block, because you notice this block, by the way, is sort of blanched out, like it looks whited out a bit. And like if I disconnect this block, the same thing happens. This happens when you have a block on the screen and it's not connected. Okay, so snap it and snap it, and the two go together like that. And I'm almost done. So a couple of things you can do is these two things here are speed control. This is amount of turns, all right, but it's measured in different units. You set the unit right here, and I'll describe that in a second. And then this is whether or not, when the motor stops turning, you want it to brake or coast to a stop. All right, and that's actually something in motors, like a lot of more expensive motors have braking systems in them, or they let them coast to a stop. Usually I find in Lego robotics, it means that it's the difference between going from full speed to zero, I think is maybe a centimeter or two. So if you need the robot to stop at an exact point, choose brake. If it doesn't matter where it stops, all right, and you're not measuring things out centimeter by centimeter, then you don't need to apply the brake. If you are, apply the brake. All right. So about the rotations, you can select here. All right, and let's just say I turn it off. I believe this just allows the motor to run forwards. Okay. When I turn on the rotation control here, you can just have it on for seconds. So this is, I want the motor to turn on for 1 second and then brake. All right. I want the motor wheel to turn 360 degrees or 1 full rotation and then brake. If you wanted a quarter turn, be 90 degrees. All right. And if you want it on for a certain number of rotations, we can do the same thing. All right. So just as an example here, I'm going to go on for degrees, and we're going to go a 3/4 turn. So for that, I want 270. All right. And you can see here the graphic, very helpful as it is. If I have less than 270, like 210, you'll see that this black portion, this black arc here, ends up, and see, it's less than 3/4 now. Okay, so it's actually kind of a cool feature. It allows you to visually tell what a certain angle is in degrees. Doesn't do radians, so it doesn't really help with my 12 pre-calc or something, but degrees, it's useful for that. So here's my program. Now you'll notice up here that it says ports B and C. All right. When you click on this, it allows you to choose what port, lettered port on the back of your robot you're going to allow the control block to control, right? And because this is move tank, you'll notice there's 2 pictures of motors here. Well, it turns out that each motor for this tank block to work, one has to be plugged into port B, one has to plug into port C. All right, and also by default, the robot should be moving forwards. Okay, so if you run this program and your robot moves backwards instead of forwards, you have to actually take cable C and cable B out and switch them. All right, minor thing. If you built the robot according to exact instructions, though, shouldn't be a problem. All right, now this next bit, well, really cool. Just because of the way I'm screencasting, it's really hard for me to switch back and forth between screencasting and the screen. And there's a bunch of stuff I have to show you on screen here. So you're just going to have to go by sound here. Okay, but you'll notice that the region right here is blank at the moment. As soon as I plug this in, like this, and I turn on the robot, and that means pressing the darker gray button in the center of the button group. All right, there we go. Now, the first thing that you'll notice is that we have a bunch of stuff right here, and we have a bunch of stuff right here. All right, so the idea is that these bottom rows are meant to be sensors. All right, so this is your ultrasonic sensor or your distance sensor. This is your rotation sensor. It's like a gyroscopic sensor. I'm not sure that it has a gyroscope in it. And this is your bump. Then these, B and C, are your motors. Okay, those are your major motors. And then you have a minor motor, which I think most people use to control, like, simple robotic claws and stuff. It's not super powerful, but it works. All right, but you'll notice here that if there is something in your robot that you've plugged in, like if you haven't if you've plugged 7 things in here and you don't have 7 things plugged in, then there's a problem, right? So just to give you an example of what happens, let's say I'm using my bump sensor and I bump something and the cable comes out. What happens? You'll notice it disappears from here. So automatically, if you see a sensor that's supposed to be plugged in disappearing, right where my cursor is down here, then you'll notice that you should be plugging something back in, and it just pops back up. Now, the cool part about your sensor, by the way, is that I can find it here, and if I bump something, watch the little numeric value here. You notice it goes to 1, and I let go of the sensor, and it goes back to 0 again. Okay, it's relatively quick. You can see, I don't know if you can hear my pressing it. I'm trying to press it loudly. The value changes within a second of pressing, maybe a bit quicker than that. Okay, so basically you can write little programs here saying like, if bump sensor reads 1, back up, you know, and then you'd put the motor in reverse or something. Okay, so what I'm going to do now is go back up here, and what you'll see is that if your EV3 brick is working, you'll see this and you'll see USB, and the two are connected. All is well with the world. If you see warning signs up here, or it's constantly updating firmware or something like that, then there's probably a bit more of a problem here. Okay, so the first thing I want to do is take the program and we're going to download it onto the machine. All right, and to me I would call this upload, but apparently they call that download. And once that's done, I can press my little arrow button and you should be able to hear something. And that sound was the robot going 270 degrees forwards. All right, so let's say I don't like that and I want some like large number in here. You'll notice that 2700 degrees, all right, should give you 7.5 turns of the wheel. But because it's already more than a full circle, it's already solid in there. So let's see whether or not we can move the program now. Okay, and that's basically it. You'll notice I tried pressing this button. I didn't seem to do anything. So I might need to have a more complicated program for that to take effect. But you know, let's say that I want this to move a little bit faster. We'll go full forwards on there, or as far forwards as I can get. And let's, I don't know, go full backwards in this case. Okay, when you do that, you'll notice that your robot should start turning. And you'll just have to trust me, it started turning. Okay, there's also another block, by the way, called motor inversion, which allows you to do this automatically without having to put in the negative signs. But that's essentially it. So you've basically gone ahead and written your very first program if you're following along. So if you've managed to get this far, I would suggest that you likely have the robot up and working, and we've done the initial programming side of this. Okay, so I'm going to call this quits because I can only put videos up that are roughly 10 minutes, and I might have to carve a bit out of this one. And we'll come back with some more complicated programs afterwards.